Hi guys, this is Gobinath, working as assistant professor in the Department of Computer Science and Engineering. And today we are going to see about the topic of Hadoop ecosystems in big data analytics. It is a huge number of data. We are going to handle the huge number of data that is using the Hadoop technology. Let us discuss about the ecosystems that is present in the Hadoop. That is Hadoop ecosystem. It is a platform that works or very it will be more suited to the uh, provide various services, that is to in order to solve the big data problems. That includes big data problems, that includes Apache projects when we are using the various commercial tools, and also it provides solution to that problem. And we have a major Hadoop ecosystem that we are going to see in the on the next slide. So it is a platform that will works provides various service to solve the big data problems. So all these tools are work collectively to provide service such as absorption and analysis of the data and storage of the data, how the storage has been done, and maintenance of the data. And these are all the components that we are using in the Hadoop ecosystem. HDFS, Hadoop Distributed File System, Yarn, that is yet another resource negotiator, and then MapReduce, programming based data processing, and then Spark, Pig, Hive, H-based technology, Mahout, and Spark ML library, that is machine learning library files, and Solar, Lucene, Zookeeper, and finally Uzi. So we are going to see this Hadoop ecosystem one by one. Uh, the first one is Hadoop Distributed File System, that is HDFS. So it is a major component of Hadoop system. It is mainly used to storing the large data sets, whether it is a structured data or it may be unstructured data, to store the huge number of data, and thereby it maintaining the metadata, that is data about the data, that is called metadata in the form of log files. So in the Hadoop distributed file system, we have mainly two components. That is, first one is name node and second one is data node. So name node will act as a master node, whereas data node will act as a slave node here. So the difference between name node and data node is that name node will act as master node. Again, I am repeating, name node is act as a master node, whereas the data node will act as a slave node. So name node is a responsible that contains the metadata, that is data about the data. It mainly is to allocating the work to the resources, whereas the data nodes are commodity hardware in the distributed that wants to execute that work. And second one is yarn, that is yet another resource negotiator. Here the yarn is the one which helps the manage the resources across the cluster. There is the huge number of clusters are there that will help to complete that particular task, that is to manage the resources. So in short, it performs scheduling and resource allocations for the Hadoop ecosystem. So how the scheduling has been done and resource has been done, you can see there are three major components. The first one is resource manager, and second one is node manager, and third one is the application manager. So what the resource manager will do, it has the privilege of allocating the resources to the application, that is to the node. That's the work of resource manager. Once the resource has been allocated, the node manager has to be work on the allocated resources. So for example, if the particular task has been allocated to the particular node, that node manager has to done that particular task, such as CPU and the memory and bandwidth for the machine. This task has to be executed here. And third one is the application manager. It will act as the interface between the resource manager and the node manager. So that's how these three components will work. And next important one is map reduce. Here we can able to split the term that into two, that is map and then reduce. So what the map will do and what the reduce functions will do. So normally map function will perform sorting and filtering of data. So and then thereby it will organize them in the form of group. So once the map generates the key value pair, it is based on the result which is later on processed by the reduce method. So in simple we can term it as, so in the map function we will generate a key value pair. Okay, so based on that result, that will consider as an input to the reduce method. So the map will generate one single output that will taken as a input to the reduce method, and this input from the reduce method will again do some modification by the reduce method, and that input has been again converted into the final output. In simple, reduce take the output generated by the map method, so that will take as a input and combines those tuples into smaller set of tuples, that is called as map reduce. So simple map will generate a key value pair as output. That key value pair output will be taken as input in the reduce method, and the reduce method will work on that. That is called as map reduce pair. And next one is pig. Pig is originally it is developed by Yahoo in order to works on the pig Latin language, normally which is query based language. It is similar to SQL, our SQL structured query language. So it is the main platform to for structuring the data flow, that is in order to processing the data and analyzing the huge data types. We will move into the pig platforms. And next one is Hive. Hive, with the help of SQL, as I said in the pig, with the help of SQL methodology and interface, Hive performs both the reading and writing of large data sets. So, however, its query language is called as SQL, that is Hive query language. Instead of using SQL, we can use here as Hive query language. This is highly scalable. Scalable in the sense we can able to extend our operation. It allows, and also it has allows the real-time processing and also the batch processing, etc. And the next one is Mahout. Mahout is similarly based on the working of machine learning concept. So as the name suggests, that it will help the systems to develop itself based on some patterns or some environmental interactions on the basis of machine learning algorithm. It may be a KNN algorithm, it may be a CNN algorithm, or various types of algorithm. It will works based on that platform. And then the Apache HBase. HBase is it's basically no SQL database. It is a main important key term here is a NoSQL database. It supports all kind of data that is capable of handling anything of the Hadoop database. It provides the capability of big data, that is, I mean the big table, that's able to work on big data sets effectively. That is called as HBase. HBase, where we need to search or retrieve the occurrence of something small in a huge database, that is called the HBase. So main concept here is it is a NoSQL database, that is no structured query language. And then the Spark, it is a platform that handles all the process consumptive tasks like batch processing. I mean split batch processing, that's nothing but we can able to split the task into multiple batches, that is called batch processing. The interactive and the real-time processing, it is well suited to handle the real-time data. And the final one is Zookeeper and Uzi. So here Zookeeper is nothing but is the management and coordination task. Once the work has been allocated, this has to be managed all, whether all the resources are allocated, whether any empty resources are available. That task has to be coordinated by the Zookeeper. So Zookeeper here, it will overcome all the problem of all the problems by performing the simple synchronization and the intercomponent based communication, grouping and maintenance. So once the coordination has been done, and then we will move on to the Uzi concept. So it is a task of scheduling, that means it will scheduling the task, that is the main job of Uzi, and then binding them together in as a single unit. So here there are two main components. That one was, first one is Uzi workflow and the second one is Uzi coordinator. The workflow will done that needs to be executed in a sequentially ordered manner, that is called as Uzi workflow. And the Uzi coordinator jobs are those that are triggered when some data or external stimulus is given to it. So that the coordinator has to be triggered when some external input has been applied here, that is called as Uzi. So these are all the components of the Hadoop ecosystem. Hope you are all understand the concept of what is Hadoop and what are all the components in Hadoop and how these components are worked in Hadoop ecosystems. Thank you.